Hello. Sorry to interrupt. Hello. Can you hear me? Hello.
Hello.
Hello. Thank you. Ardell, thank you. Um, thank you for doing that without volunteering. Thank you. So you here. Thank you guys who survived. All right. So I left. I came back. I apologize. Thank you for hanging in. I don't know if you guys made any progress. All right. I'm catching up here. So yes, I don't know if we're going to deal with that sheet thing on a spring. That's what we're going to get to. Maybe you made some progress. We're going to find out in a second. But I want to catch up with you. Thank you for holding together the class while I was in another universe. Um, Bear with me for one more second. Um, I still owe you guys a proper syllabus. I mean, a formal syllabus sheet, which I will put in the stream soon. The rules and procedures and stuff like that will be familiar if you've taken 203 at John Jay, but I will put that in your stream anyway. Exams and so forth will work the same way, as in they will be like someone asked in the other class, when is the final exam? The final exam will be a take-home exam that will be due at the end of final exam period. So again, this is kind of like what happened last semester, if anybody knows. But just to answer questions right away, final. Oh yeah. Oh, okay. Yes. How many exams do you have? You have one midterm and one final. They will both be take-home exams. We'll discuss them more when we get closer to them. But they'll both be take-home exams that are submitted into Google Classroom. The final exam, you'll have essentially the exam period to do it. Like it'll be posted right before the exam period, at the after the end of classes. Um, in fact, I think I just put in my someone. I think the exam period ends May. You can look this up, or I just did look it up a second ago. But I think the last day of exams is May 19th or something. Whatever that last day is when your final exam will be due. To me, the midterm, I have not announced or put a date or anything. It will also be take home, but most likely, to be honest, I'm going to talk over with Woo this weekend about a bunch of things. And so then Monday, you guys can remind me. Monday, we as a class can settle, we can confirm and finalize the date for the midterm. I mean, like I'll probably come with a suggestion to you, but then you can tweak it and we'll finalize it this Monday. That'll be for the midterm. So there'll be one midterm, one final, both take home, both hopefully will be legitimate experiences that will show that you know some physics, but hopefully will not be too stressful. Hold on, I'm just getting the board ready here too. Just catching up again. Thank you for your patience. I'm happy today. Today, oh, so we are now recording. I did. Oh, that's another thing. I did not post yet anything. Sorry, I did not. Now you have two of me. That's exactly what you don't need. Hold on. Okay. 1 second. All right, this is back to where we are today. What was I just saying? Today we are going to like get into some physics. We're going to start going over this sheet thing on a spring. Technically, I put it in the stream to be due today. I haven't even looked yet to see which one, and I will look in a second. But we're going to do it. You want to have turned this in by the end of today or by the next couple of days. Like there is another assignment you may have already noticed that's already due next Monday. That's in your Google stream, but that's just so that there's always something to do. Like at any given moment, anybody in this class should have a next physics thing to work on, not to make them feel behind, but there should always be something physics for you to do. On the other hand, I don't want anybody in this class ever to feel so far behind that it's too late. Like it just shouldn't be that way. There at any given moment, even if someone does get very, very, very far behind in the class, if one of you does, or if I do, still at any given day, you should be able to wake up and say, hold on, I want to grab the bull by the horns now. Have I lost it? I hope I haven't totally lost my opportunity to do good with this. And hopefully there will always be a way right up until the final moment. I mean, right up until the final exam for, to salvage a situation that might not seem unsalvageable. Why am I saying all of that? I'm saying that we're going to start going over homework 1 today. If you did already turn it in, then I'll see that in the stream. I'll see that you already turned it in and I'll be impressed and happy. If you haven't turned it in, you still can and must turn it in at some point by the end of today, or even during the weekend. No one will be punished. It won't be counted as late or anything like that. But we will start going over some of the answers today and stuff. And the more you use those answers to turn them in, that's fine too. But just know that I know that as well. So for example, just not to drag this out, but some of you know me, some of you don't. If one of you actually did do this whole sheet already and turned it in, which is great, and I will notice that even though I haven't given it back yet. If we're going to start going over it today, and we'll continue to go over it Monday, we're not going to finish it today. We're going to start giving some answers. So one of you who, if you did it already early, if you did it already, but now you're seeing that one of your answers is wrong, you can feel free to correct that and upload a new version of the assignment, and don't take back the old one. Then all I'll see then is that you're that hard of a worker. I'll see that you worked it in advance earlier than a lot of other people. And then you went back and paid attention in class and corrected your work and updated like the new corrections. That's just all to the good. In other words, what I'm trying to tell all of you is any bit of work you do, upload it. And don't worry about whether it's like late or early or something like that. Like the earlier it is, the more I'll notice and the more work you'll do. But the later it is, you're still doing the work. So feel free to correct and upload and stuff like that. And also don't, if you did something responsibly, like before today, now we start going over it. Now you notice that other people are starting to turn it in after today. Don't feel that that threatens you. Remember, there's no limit to how many you're not in competition with each other in that way for A's in this class. Like whatever competition there's, I'll explain more later. Now, yes. Great question. But great questions. I'm sorry, I missed. Okay. So backing up to these questions in the chat. And what I meant to say is today is largely for this. Like I have not put a syllabus in the stream yet. I will. I would like to, not bore you people. I'd like to get to some physics and start doing it. But the more we can make this, I said this in the other class too, this is a synchronous class. Like you are expected to actually join me in my Zoom world twice a week at this time. It's a pain in the butt for you. It's a pain in the butt for me. Like obviously sometimes I'm even late, like today, because I have to pick up. And in fact, this may be an issue every Wednesday. I do have to pick up my son at school before this class. It should work out fine if there isn't a big snowstorm and blah, blah, but blah, blah. We all have our lives. It's hard to do these Zoom classes, but what I want to emphasize as much as possible is the more we can get done together as a group here in this rough 75 minutes, like the more we can calm ourselves and do physics, the less we have to stress outside of these 75 minutes. That means you and me. So why am I saying all of that? Oh, thank you so much. Oh my God, thank you. Wow, that just changed my life. Thank you. My wife, ladies and gentlemen, just brought me a snack. That's so nice because she hears me suffering. I'm not really suffering, but it is really nice. But what I want to say to all of you is if you look in, some of this is like boring old news if you had me for 203, but there's like a slight new concrete addition to this. Sorry, that I want to direct your attention to in the stream. But on your questions in the chat, which yes, we are here today to answer. Anything like this that we can answer today and make the class easier, please. It's definitely what today is for. So first of all, will review sheets be provided for those exams? Yes. Yes. I mean, that's definitely our intention. And occasionally the review sheets come a little bit later than we wanted, or they get closer to the exam than we wanted, or occasionally, sometimes we'll give you solutions to some of the questions on the review sheets. Let me back up. Review sheets. I mean, the answer is yes to Isabella's question, but I don't even call them review sheets. I call them practice exams. I mean, there's a subtle difference. Like we will give you guys sheets of all the equations that you need and that you use in the exam. And in fact, we give that sheet in the exam. So it's not a matter of memorization, but as far as review sheets, like traditional, like outlines of material or something, we don't do that as such. But what we do, and I think maybe Isabel might remember, some people remember this from last semester, we will give you a practice version of the exam before you take the actual exam. The practice exam will be incredibly similar to the actual exam. And we will often give you a bunch of solutions to much of that practice exam. We won't always give you the solutions right away. Like you might have to think about the practice exam first. We sometimes will leave out certain solutions. And if we do, then we'll say this exact problem, if we didn't even give you a solution, we'll say this exact problem is going to appear as is on your exam. So it's basically just like huge amount of advance warning or notice to work on it with each other as much as you can, even before the exam comes. So long way of saying, we definitely give practice documents for these exams. By the time you take an exam, we don't want you to be very surprised to see what's on it. We just want you to know how to do it. So we never do anything perfectly. Like the practice exam, it ends up never being quite as much time as we'd like to give you for it. We never go over it in every single detail of it as slowly as we like. Sometimes we make extra lectures where we go, sorry, someone's entering, sorry. Sometimes we'll make, in the practice exam that we give you, if we don't have time to walk through all the solutions or something like that, sometimes I'll post an extra, like an optional lecture on YouTube or whatever that you can watch at night and see me go over the practice exam. That's like a review session. So these are good questions. And again, I'll be more specific when we get close to the exam, but definitely you don't take the exam blind in this class. Like, you should know what the exam is going to look like before you take it, if you want, and you take home anyway. So and yes, we review and the midterm exam please remind me. We'll try to settle the exact date for that in our next class this Monday. You can remind me. And then if we are forced to change that date for some reason, then we will, but there's no surprise tests or anything like that in this class. Like I wouldn't be able to grade them if I did. Now, the other question, so that's a good question. I hope I answered it. And the other question in the chat, Amanda's question, homework, the way it's graded, is totally about very good questions about completion, not correctness. Now, sometimes I'm not going to be even very complete in grading your homework. Like, I certainly have my imperfections too, to put it mildly. What you want to do in homework is you want to make a specific point of neatly and clearly addressing every different question, like label it, like here's question one. And you don't have to recopy the whole question or anything like that, but make it clear this is question one. Solving, like question one is what's the force or something, F equals question mark, then show some work. Then, and I'll show you when we go over this in a second, but then get the force, whatever the answer is that we're looking for, and box that answer, like force equals 30 newtons or negative 30 newtons or whatever, and box that answer. Now, if you've done that, if you've shown this is question one, this is my work, this is my answer, and like if you've made it clear enough that I can literally look at that homework, imagine me looking at your homework without having the questions next to me, right? You don't have to recopy them or anything, but your homework has to just make enough sense that without looking at the questions next to me, I can follow it. Like I can be like, oh, question one. And even if I don't perfectly remember, which generally I do, but I mean, with these homeworks, but you can make it clear to me that even if I don't remember the sheet, I can understand what you're saying there. Oh, she's solving for a force. He's solving for a force. Oh, and he got a force of 30 newtons. Now, if you do that, you can get full credit on the homework, full credit on every homework, which is a ton of extra points, even if every single one of your boxed answers is wrong. I mean, so I'm answering Amanda's question, but it's a very fair, very important question. Even if I've said this before in 203, it's like even more important than true here because these things do get hard. The physics does get hard. Your job is to complete the homework, to get the points for that homework. Also, if you never complete a certain homework, you're just never getting the points for that homework. I'm not going to track you down. You're not going to get an F or something. You don't get a 0% or anything. You just don't get anything if you don't do the homework. And if you do it late, you do get something. But what I'm looking for when I say something, and not to beat a dead horse, but is completion and thoroughness and clarity, not correctness on the homeworks. That's absolutely right. I mean, if that makes it to Amanda's question. Okay, so that's Amanda's question. That's Isabel's question. 2 exams that we have. So again, please feel free. I'm going to turn in a minute. I want to turn to a thing on this, to the material. Yeah. No, I have to turn to a couple things like that. But any one of you who's asking these things right now, and again, this will go on YouTube later if you need to review, but these are not, you're not getting me off the topic. These are like what I'm here for. And it makes me feel more like we're together if you're asking. So keep these questions coming. Seriously. The 2 more things I want to remind you, I'm just trying to change the view here so I can see you guys. Right. Okay. I put in I think some of you are getting used to, like last time I put in that thing in the stream about 50 points for class participation. I will keep putting those things in the stream, but now you hopefully today saw a new one, which says, and please confirm or deny if anybody did anybody see in their stream something that says a game your best or something like that. A game your best. It's worth 100 points and it's due never or due every. Oh wow! Thank you so much. Wow! Oh, thank you. Does anybody see that? Does anybody hear what I'm talking? Or tell me I've been on mute this whole time. Oh no! Oh, you don't. Okay, hang on one second. Thank you. All right. Well, that's important. Let me do this right now. Hang on, and keep working on thing on the screen. You don't see. Okay, I believe you. I totally believe you. Let me do this right now. I don't know what happened. Hold on a second. I'm glad I asked. Okay. Okay, tell me if you should now, in a moment, you should see in your Google stream, there should be an assignment that says a game, your best. Tell me if and when you see. Oh, yes. Thank you, Ardell. Okay, that's it. That's one person. Great. Okay, thank you. And it definitely was not there before. Great. Okay, thank you. And so it wasn't there before, but it is there now. Cool. What that is, let me just make this clear. This is a slightly new thing. It again has to do with, okay, great. Thank you. And any one of you who said yes, that counts as class participation. Thank you. Anybody who put yes or whatever in the chat, that's great. Okay, what's the purpose of this assignment portal? I think this is going to be helpful to a lot of you and hopefully helpful to me. The point here is kind of like what it says. It's a running thing that you can use at all times and you can change what's in there. It's basically, this assignment portal is for you to direct my attention to the best of you, particularly at any point that you think or that you're worried that I'm about to sit down and have to deal with grades in any way, like especially like on the last night after you've turned in all your exams and I have to submit calculate grades and turn them into CUNY first. What I want you guys to know at all times is this portal is where I will look first to look at who you are. Like, in other words, and this is kind of a new thing. I hope this will make sense to everybody once I've explained it. But I'm saying, like, I'm saying I want to grade you on your best. And I want you to know that in advance. I also want you to know that, well, yeah, I want you to know that. So what does that mean? It means, like, say on the one hand, say we get to the midterm exam and assuming you get it back in time and stuff like that, say a couple of you know that you feel pretty good that you did well on it, or you rocked it, or you in fact find out for a fact, for me, like you get a 96 on it or something. All right. And that's good. But then we're sailing towards the final exam and things are happening. And for whatever reason, like because something's happening in your family or in your brain, or the material's getting too hard, or you're falling apart, and you see yourself cruising toward that final exam, and you know this is not going to be your finest hour, and you're panicked that now the good work you did in the beginning of the semester is going to be ruined by what you're about to do. What I want in that, that's just one example, but what you would do in this case, in this example, is you'd put a copy of your midterm in this portal. Or you would even just put a note in that just says, please look at my midterm first. Please don't forget about my midterm. Or please remember I rocked my midterm. Or let's go a step further. Let's say you didn't even do well on the midterm because you had a bad day or something. But like you've been rocking in class, like you participate every day, you're always talking or stuff, and you've been sending me screenshots of like how you participate in class. Then in that portal, I want you to write a note to me saying like, please remember I'm the one that's always, please remember me, I'm the one that's always making jokes in class or something. Or even literally just direct me to a screenshot right there of something that you once said in class. Or last example, maybe the most important one, homework wise, some of you are going to do good home, you're going to have good homework days and bad homework days. But if for any one of you, if there's a homework that you work particularly hard on, like you might've gotten it very wrong at first, but then you totally pay attention in class and then you really get it and you really feel like now I get this and I didn't before, or just a homework that you just rocked on your own, whatever. If you have something, your best work, just put it in that portal. And the minute your best work changes, of course, like, you know, you have one piece of homework right now, you could put in, if 3 days later you have something else that's better, take out the old and put in the new. And if that doesn't work, let me know and I'll tell you how. But I'm basically just, I'm saying, think of this as your your way of directing my attention and influencing me to give yourself the best possible case for an A at all times. That's really what it's for. It's like, if there's any doubt in your mind, like if Yaverbaum grades this way, I might not get an A. But if you were to look at this, I might. And, you know, of course, it doesn't have to be an A. It could be a B or whatever. But if at any moment you're thinking, I really wish Yaverbaum would be first and foremost aware of this piece of me, then put that in the portal. That's what it's for. And it's not a trick. Remember, this is also going to make my life easier too, because I don't want anybody to get bad grades. So any good reason I have for giving someone a good grade and being able to defend it years later in a court of law or whatever is fine by me. So you're just helping us both by defending yourself at all times of like what you're doing in this class. Does that make any sense? Like, can I get any, and if you put nothing in there, that's fine too. If you put nothing in there, I'm never going to hold it against you. But then at the end, I'm just going to grade normally. Like I'm going to, you know, put down your final grade and your final exam grade and your midterm grade and all that stuff. And like, if it doesn't come up in your favor and I've got nothing to work with, it'll just be harder for me to work with you for you. Okay. Does that make any sense? Oh, sounds, oh, cool. Okay. That's one person. Oh, that's interesting. Oh, great. Okay. I see that. Thank you, Lydia. Thank you, Arlene. Actually, now Isabel's question, that's really a fair, I mean, that's an interesting question. I have to say, given the way and because we're first trying this now, I do have to say, I'll think about it and get back to you, but right for the moment, please don't submit anything from last semester. Like you're right. That's an interesting question because in cases of some of you, or like maybe even Isabella, it might help remind me of like really who you are. And then that might help me like understand you better when I'm looking at your work this semester or something like that. But I think that might be pushing this boundary a little too far. What I really want from anybody and everybody is, and again, many of you may never need to use this, and that might be fine. Like, especially if you're just confident that your midterm grade is going to rock and your final grade is going to, then that's fine. But you really can use this also just for any homework or just anything that you're proud of, just to make it easier. Yeah, but it has to, yes, I have to say it has to be from this semester. At least let's start with that rule because I'm not really sure how to, okay, all right, cool. But thank you for, okay, I'm going to assume from those people who said yes, that's good. All right, cool. So that's what that portal is for. Then finally, just logistically, I'll say, I think you'll notice I also put in, I think, or can you confirm, I put in a homework number 2 called like mathematical methods. That's technically due Monday. Let me say again, we're not going to get to it Monday. It's technically due Monday, just meaning that it comes after the one that's due today. I can already see it's definitely the case that Monday we'll still be talking about homework 1. So by Monday, you certainly do want to have turned in homework 1. Like it would be a mistake to not have thought about homework 1 at all by the time we're talking about it for 2 days. But homework 2 comes next. Do it next once you're up to it, or if you're frustrated with homework 1. But again, I'm telling you in advance, it's technically due Monday. I doubt that we'll get to it Monday. So that's just the way it is. So you can stretch it out with your judgment. All right. I want to turn, I'm just thinking if there's any other. Oh, last thing is the Zoom link. Hopefully the Zoom link to this class, I think someone suggested yesterday had it. Is it fairly easy to access now? Like, can you get to this class easily when you have to, or is there a way I can still make the Zoom link more? Is that a yet? That's a yet. Okay. Cool. It's there and it's like easy to find. All right. Cause I wish I could do that better, but all right, cool. Okay. Then I want to, oh yes. Okay. Then I do want to turn to thing on a spring, but I guess, yeah, I have a little background material I have to give you on that. I want to turn it to you guys to start talking about it with one another because I know this is boring just to sit here and listen to me lecture. But I also know that thing on a spring, okay, it's supposed to be a transition problem. It's supposed to start getting us into the new material of physics 2. I have not yet really explained what's the difference between physics 2 and physics 1. Like how is the material different? And on a fundamental level, it's not. On a fundamental level, both physics courses are like all physics courses. They're about motion through space and time. The things that are moving turn out to be a little bit different in physics 2. Like in physics 1, we're looking at the motion of more mechanical things. And physics 2, we're looking at non-mechanical things, like electricity. I will be more elaborate about that. But the transition of one of the ways to transition from physics 1 to physics 2 is to study the motion of springs. Springs are very fundamental. They can seem very obscure and like very picky at first. Like we're going to spend a lot of time just talking about a freaking spring. Yes, we are. We're going to spend a lot of time talking about a freaking spring, really, because what we're really talking about when we talk about a spring is we're talking about springiness. What we're really going to be analyzing here is what it means for some system to be elastic. We're not caring so much about like a coil of metal. Like that's what you're picturing in lab. And that's what this problem is picturing, like a tightly wound coil of metal extending and compressing back and forth. That is what we're studying here. But the real reason it turns out we're studying what it means to act like a spring, to behave in a springy fashion, in an elastic fashion. And it turns out anything that behaves springily can be thought of as being made up of little springs, but they don't have to be little metal springs. Anything that behaves elastically could include molecular bonds that act elastically, or could include gravitational effects in a tunnel through the earth, which act elastically, or could include magnetic fields that act elastically. Elasticity is really a phenomenon or a property that we really are going to dive in and start studying here, because it will link, it will get us into physics 2. That said, I want to make sure you have some clear background on springs. Like people come from different classes. I don't think I cover them very well, if at all, in my class last semester. So again, at the risk of boring anybody, but just in the effort to be clear, I want to turn your attention to this next page on the screen, where I'm trying to explain. So I'm backing up on this problem thing on a spring. We're going to analyze it. We're going to get the numbers, but let me make sure we all know what a spring is in general. When I say, so hence this picture here. And again, please, anybody interrupt me if I'm already driving myself crazy just talking like this. But when I say that a mass is on the end of a spring, I'm picturing some kind of horizontal, I'm picturing right now a coil of tightly wound metal. And I'm picturing a coil that's like very long, let's say, and a coil that is free to extend a little bit in one direction or even compress a little bit in the other direction. In fact, I'm picturing a coil that's nice and long enough and tightly wound enough and uniformly wound enough that, in fact, it's never being asked to stretch out. Like it's really long. So I only ask, say it's like 15 meters long. I only ask it to stretch out like 15 centimeters to the right. And I only ever try to push it like 15 centimeters to the left. So I'm never, in other words, what makes me believe that my spring is going to behave well is I never ask it to extend or compress too much in comparison to its entire length. And if I never ask it to do that, and if its entire length is pretty long, and if it's tightly coiled, uniformly coiled, then it tends to end up being able to extend pretty much as equally as it ends up being able to compress. Like springs, we picture the ends of springs being able to go in two directions freely. We picture our first spring as horizontal, even though I know in lab, often we deal with vertical springs. We first, in theory, picture a horizontal spring so that we don't even have to be distracted by any possible effects of gravity. Now, let me also say as a side note, it turns out in lab, it's easier to measure and work with vertical springs. That can be a little confusing because it seems like then you have to worry about gravity, and you do have to worry about gravity. It turns out you don't have to worry about it that much. So we get away with using vertical springs in the lab. But here in this problem, we picture a horizontal spring. So the only force acting throughout this entire problem is going to be, the only force acting on that mass is going to be exerted by our spring, no other forces at all. One edge of the spring is tied to a wall. That's the left edge of the spring. So we assume it's totally rigid. The other edge of the spring is free to move back and forth to the right and to the left. So we put a mass on there, both as a way of focusing our visual attention, like the mass is what we picture doing all the motions that we're going to observe. But also the mass is the object that receives the force exerted by a spring. Ultimately, what a spring is to us is like a force exerter. I mean, it's like the tension in a string, or it's like the friction in a surface or something. We're using the spring to exert a push or a pull onto the mass in question. Like the mass in question is like our object of attention. It receives activity. The activity is the force exerted by that spring. So a long way of saying the spring itself is not considered to have much mass. It's way lighter than the M object. The spring exerts forces, it doesn't receive them, is the idea. So what kind of force does the spring exert? Okay, this is the part I have to say. Again, some of you totally know this, some of you don't. The kind of force that a spring exerts is really the thing that we want to start looking at here. Like what we know, what we know in physics in general, and it governs all of physics 1, and we still believe it in physics 2. Sorry, what we know in the background always is this. Okay, like just to remind you or whatever, we know that for any given one mass, the sum of all forces acting on that mass will produce the acceleration of that mass. Like if you want to know the instantaneous acceleration of something, you got to know all the forces acting on it. That's like the fundamental hub of physics. Now that's still true in physics 2. I mean, it was true from physics 1. It's still true in physics 2. However, but that just says in general, if you want to know how something accelerates, you got to know all the forces acting on it. There are different forces in the world. We're going to continue to look at these different forces. We looked at friction last semester a little bit. We looked at the tension in a string. We looked most primarily at the gravitational force. Here's a new force called the spring force, called the elastic force. It's like all other forces in that what it is a push or a pull that ultimately contributes to the acceleration of objects. Like the spring force has the same impact on the world, has the same effect, the same consequence. A spring force, just like any other force, will contribute to the left side of that equation and produce accelerations. But every force has its own mathematical nature. Like the friction force, you might remember, depended on how hard two things were pressing against each other and depended on how rough the things were. The gravitational force depends on mass of an object and on that 9.8 number. The spring force is the first force we look at. Spring force is different from gravity, and it's different from friction, and it's different from the tension force or any others that we've ever mentioned, in that the spring force is variable. It changes as a function of position. That is what this graph is trying to say right here. It's trying to say, and this again, this is definitely new information in terms of nothing else we studied in physics is like this until this point. It's not new if you've heard this before about springs, of course. But the first thing about a spring that makes us care about it is that when a mass, when you set up a spring, when you set up one side and fix it to the wall, and then you just put the spring there and you just let go of the other edge of the spring, and it's just sitting there in its relaxed equilibrium spot. If it's just sitting there in a place where it goes without help, we call that equilibrium spot x equals 0, right? Like if where the edge of the spring is in a relaxed state, we call that x equals 0. We call that the equilibrium spot. If you put a mass there and you put a mass there, you can just leave the mass there and walk away and nothing will happen. The mass will be happy there because it's equilibrium. What do we mean by equilibrium? I mean, in fact, let me write this on the next page. Now this is a nice, simple, but very important definition. Whenever I say equilibrium, equilibrium comes all the time up in chemistry, in biology, I mean, in all the sciences, in physics. If we talk about an equilibrium position, like the position where where the edge of the spring is balanced and happy, and where we call it x equals 0, what we specifically mean by equilibrium is the place where all forces are balanced, where the net force is 0. This is important and sort of not obvious, I mean, in a way, because it's what we... To be as clear as I can be, I'm saying that the definition of equilibrium is where the forces are balanced, which either means there's a whole bunch of forces and they're all equal and opposite, or there's like 0 forces, or or there's 0 forces, but where the net force is 0. Therefore, the equilibrium position for any system is the position where an object placed there would have an acceleration of 0. Like net force is 0, therefore acceleration 0. Sounds obvious, but I'm not saying that. What I'm saying is that equilibrium does not mean velocity equals 0. People often think that. It's very easy to slip into the habit of unconsciously thinking that by an equilibrium position, we mean a place where things are at rest, where things are sitting still, where velocity is 0. I want to warn everybody right now, that's not actually what we mean by equilibrium in physics, or really in the other sciences, even though it seems that way. Equilibrium means a place where acceleration is 0, not necessarily a place where velocity is 0. Put one last final way, equilibrium is the place where if you happen to be sitting still there, then you'll continue to sit still. Equilibrium is the place where if something is placed there, it will stay there. But if something happens to be moving through there, that's no contradiction at all. A thing can move. There's no law that says things can't move at or through equilibrium. We're totally going to see, if you've already done the homework, you see in the very fourth question, we already have something zooming through the equilibrium position with a speed that's non-zero. What has to be 0 at equilibrium, I'm saying way too much, but the definition of equilibrium is when the force is balanced and therefore acceleration is 0. What this all has to do with springs is that springs say, so here's now the graph, I'm blowing up the graph that I had on the first page. I'm going back to this, but I'm actually now, well, yeah, let me go back. I'm sorry. I'll go back to this right here. What I'm saying on this first page then, and again, I apologize if I'm dragging this out. I don't know why I keep apologizing, but what I'm saying is, here's the difference. Oh, okay. Here's the difference between a spring force and a gravity force. And again, even if we only get to question 1 of this sheet today, it's okay, as long as all of us feel like we're clear on springs from this. The difference between the spring force and a gravitational force is that gravitational force is constant, or approximately constant, depending on position. The spring force is not. What I mean by that is, like, here's a piece of bread that my wife just brought in. Very nice. I mean, terrific. Okay, I appreciate it. Here's a piece of bread sitting here. It has a mass of m. Okay, well, here it is. It has a mass of m. Therefore, it has a weight of mg. I mean, to be more specific, if this piece of bread has a mass of 2 kilograms, right, then its weight is like 2 kilograms times 9.8 meters per second squared. Like, it's like 19.6 newtons would be this piece of bread's weight, right? Not trying to confuse anyone, but that's the fact. Its weight is mg. Now, the deal is this. That weight is how hard Earth is pulling the bread down toward it. But just to be clear, or at least to go based on what we've learned in Physics 1, if I'm holding the bread here, higher up, or way here, way lower down, its weight is still mg. I don't care where I'm holding it, its weight is mg. In fact, and if mg means how hard the Earth is pulling on it so that when I let go, it falls down, while it's falling, its weight doesn't change. I mean, truthfully, it does slightly, but basically mg is mg, g is g all the way down. The force doesn't get lesser and lesser as this thing gets closer to the ground. It's a constant force, gravity is. The spring force, the elastic force, is the first force we look at that varies as a function of position. With the spring, if you put a mass, now I'm looking at my picture here on the, if you look at that mass and place it right at x equals 0, right? Then it just sits there. Why? Because the spring, because it's happy, it's equilibrium, the spring won't exert any force on it at all. I mean, with nothing to balance, nothing. As you pull the mass out from x equals 0, if you pull it to a spot of like x equals 1, now the spring will start yanking on it and trying to get it back to equilibrium. And if you pull it out to position 2 meters, if you pull it out twice as far, the spring is now going to yank on it twice as hard. Like on the one hand, I'm saying the spring force varies as a function of position. That is new concept because gravity did not do that and friction did not do that and tension did not do that. On the one hand, the spring force varies as a function of position. And by the way, that's why people go to the gym and use, I've heard, I mean, not people that look like me, but people that like are in shape and go to the gym and use like equipment that has springs and stuff in it and tension. If you think about it, that's the whole idea behind all the exercise or anything you do with spring based things is that is that if you're doing something like this, the farther away you're holding it from somewhere, the harder you have to work. Like that's, and you don't have to work at all when you put it, the thing where it belongs. I mean, I guess that, so what I'm saying is on the one hand, the spring force varies as a function of position. On the other hand, because this is the way physics always goes, we look at springs first because for anything that would vary, springs vary in as nice and simple a way as possible. Like it's not a horizontal, the graph of this graph of force as a function of position is not a horizontal line the way gravity would be. The force is not constant, but it is a line. It is a line that starts at 0 and goes up with constant slope as easily as it could possibly be. In other words, if you double the displacement, you double the force. That's what a spring is. A spring is a linear pulling machine or a directly proportional pulling machine. It pulls in a way that is directly proportional to displacement from equilibrium. That's why we like it. In other words, if you were to make a graph of force as a function of position, you get a straight line. You get something whose slope is never changing. What is the slope of that line? Like the slope of the rise over the run, the amount of newtons that you get, the amount of additional newtons that you get for every additional meter of displacement. Well, that constant, that slope of that line, we call K. We call K, it's measured, here you go. It's measured in newtons per meter. It's how many additional newtons of force the spring exerts for every additional meter of displacement. So what that is, that K, that is the identifying stiffness of any spring. In other words, from here on in, if I say spring in physics, I mean an object that exerts a force that is directly proportional to displacement, and the exact proportionality of that force, the exact number that you'd find being the slope on a graph, well, that is called K. It's measured in newtons per meter. It's usually a number in the hundreds, like in the spring that we're talking about in this homework assignment. It's like 200 newtons per meter. That's a fairly strong spring. A weaker spring would be like 150 newtons per meter. And if you have like 1,000 newtons per meter, that's really, really stiff. Like that means like for every little millimeter that you pull out this spring, it yanks back super hard. Like that's what, so K is the stiffness of a spring. It is the constant of proportionality between force and displacement. It's the first time we have a constant like that. Like, this is the first time we have a force that does a thing like this. But then one last detail. I know this is a lot. Again, we'll pick up on this Monday. I know it's just about the end of class, but one last thing. Sorry, one last thing. Yeah, to put this all together, and again, maybe you know this already, and I apologize for being dull, but the law that governs the nature of any spring is called Hooke's law. Hooke was a contemporary of Newton's. I mean, saying late 17th century to mid 18th century, they were rivals. But Hooke's law for a spring is ultimately technically F equals negative kx. What I'm saying here is that the first graph I gave you on the prior page was like just to give you the concept, the quality, the fact that it's a straight line. But if we're going to be really detailed and precise about this, truthfully, that graph I gave you should really be in the lower quadrant, because truthfully, the law says that whatever your displacement is, the force must attempt to restore you to equilibrium. So it always points in the opposite direction of whatever the displacement was. Again, I'm looking at the time. I know we have like 2 minutes, but if X say on the picture that you're given for this assignment, if you just assume that to the right is called positive and that spring was displaced to the right, then the force acting must be to the left, must be negative according to this law, which hopefully makes sense. And therefore, to be really fast, I didn't give you guys a chance to talk. I'm so sorry, but just so you know, here's the answers. I know we have 1 minute. I'm just going to tell you what, just so you know if you're doing it right or wrong, because I think the first few are kind of plug and chug. But if you got these wrong, you didn't get them, we will go over these on Monday, what I'm about to say. I promise. Like we'll carefully go through the sheet Monday. I apologize, but I just wanted to bring you up to speed. But the first answer is negative 30 newtons. I'll just say it, I guess. The answer to the first one is, and I think it should be negative, strictly speaking, but negative 30 newtons for the force for the first one. For the second one, the answer is that divided by 0.3 is 100, negative 100 newtons. For the third one is 0. And then for the fourth one, which takes more work, I mean, I haven't said anything about the fourth one yet. We'll have to pick up on this on Monday. I apologize. But just so you know, the answer to the fourth one is, I believe, 3.87 meters per second. I mean, I am rounding, like the digits do go on forever, so I'm chopping off digits. But the answer to the fourth one is approximately V equals 3.87 meters per second. And the answer to the fifth one is 0.095 meters. I'm only saying that so that those of you who are doing work or are like waiting for something concrete here and are, I'm just giving you that for satisfaction so you know you're doing it right. We're going to fully go over that Monday and we're going to push on with the material. And I'll give you a syllabus, but that's all I think I want to say for them. If I'm good, if you guys are good, and let's just do this thing. If you're ready to go, like just right before you leave, just like shout out goodbye or write in the chat or pop on your video for 1 second, just do something human. But I'm good if you guys, but I'll stay if there's questions. I mean, I'm not going to go till you guys are gone, but I'm good if you're good.
I just had a question about the participation, like how we submitted it on Monday. Do we have to submit our participation every time we have class, or is that just something once in a while?
Oh, wait. Oh, no, that's a great question. And that's a great question. And also, I just realized I'm rushing because I was thinking the class ends at 4:05, but technically it ends at 4:10. Wait,
it ends at 4:20.
Oh, wow. Oh, my God. Oh, you're so sorry you just said that. Okay, wait, no, good. All right. I'm still not going to. All right, then I'm going to relax for a second. In fact, that's a really good question about the participation. What I mean and I'm going to pause. In fact, I'm going to put something in your portal right now. The idea with the participation is, in theory, I'm going to put a participation portal like that, at least one, every single time we have class. Like even right now, I'm going to put another one in right now. So and there's going to be other different ones too. In theory, every time there's a class, you are invited to record anything you said or whatever into any portal that you see for that day. Like I'm going to put a new one in for today right now, and I will put one in every day. So yeah, it is actually something that hopefully every day you have an opportunity to remind me of something you did. Furthermore, again, I think we did this last semester, like some of these portals will be more detailed. Like I might open a portal for just any time someone actually put a screenshot in the chat or something, like extra points for that, blah, blah, blah. But yeah, it is, before I forget, I do mean for it to be every time. Like if I forget to put in a portal, you can remind me. And furthermore, you guys, it's meant to be an opportunity every time, but like 2 weeks from now, you can catch yourself up to, if you remember or you have record that you participated in today, you can still throw that in a portal 2 weeks from now and it's fine by me. It's really just more meant to be so that every good thing you do somewhere gets recorded somewhere, even if it's 2 weeks later or something. So I mean for you to have portals like this every week. So I'm going to put one in right now before I see there's other questions. Just hold on a second. Let me just put in the next one before I forget. And again, oh no, thank you. And some of you, again, you could never fill out one of these. You could literally ignore all of them. And if you get 100 on the final exam or whatever, if you get an A on the final exam, no, let me be more clear. You could never do any homework at all. And you could never submit any of these class participation things. And if you get, a 95 on the final, 95 on the midterm, and if I legitimately really, really believe that you really did, and it wasn't a cheating thing, and we'll talk about that, whatever. But if you do that, then you're fine and you have an A in the class. Like none of these things you don't have to do what I'm talking about here with the participation, but I think for a lot of people, it would be a much easier way to get an A in the class is to keep up with these kind of things and give yourselves a cushion. You know, you can think of it as extra credit that way. And to give yourself a cushion, like for some of you, let's say you might not get an A on either exam, but if you do enough of these and stuff, it's still super conceivable to get an A in the class, or B, or whatever is your goal. Wait, so what was I just gonna, so again, that goes to that little portal where I said, give me your best here. For some of you who are going to if you struggle on the exams or stuff, like that's your opportunity in that other portal to say, like, I always rock in class. And like, you know, I want you to know I've got 100 like class participation things in there. Please remember that, Yaverbaum, or whatever. But here, let me give you, yeah, so let me give you the next one right now. Hold on. Sorry. And then we will go. Again, the next two. But yeah, I think, well, no, all right. Hopefully, let me just see the chat. Oh. Okay. All right, now these are good. Again, this is good. Two things. One, so homework two, the one that is mathematical methods. Technically, I suppose actually, I'm going to change that right now. Technically, I think it's due next class, but I know, especially now I see where class went today, we are not going to get up to homework two in the next class. So let me be as clear. I'll even change the date on it right now. What's really due for everybody, if you already did homework one for today, that's great. And I will see that. I can see it. And you will get, in fact, I'll look right now. But really for everybody, what we're going to spend the majority of, what we're going to spend all of Monday doing is going over homework one, because I've been talking a lot today. So all anybody has to do for Monday, I mean, what you would want to do is definitely do your best on homework one. If you're done with it, you can go ahead to homework two, but no, nobody needs to, I'm going to change right now. You don't need to hand in homework two for Monday because we're definitely not going to get up to it. So hold on, let me just change that right now to make it clear. Oh, I think that is clear actually. No, it's not. All right, I'm going to change that right now. Sorry. And then ask you one other question. And then we'll probably go, and that's fine. Okay, so homework two has now just been officially changed to be due Wednesday. All you have to do, not all, but what I want everybody to do is as seriously as possible for Monday is homework one. Oh, and I'm looking right now. So 9 of you have already turned it in. That is terrific. I'm looking, I see that you did. I'm proud, I'm impressed, I'm happy, and I'm not being sarcastic. 9 of you have turned it in. You did your job. Even though we didn't get to it today, you are ahead of things. You are going to heaven and all that. But 11 of you have not. That is totally fine too. The 11 of you have not turned it in. Just try everything you can on this sheet to do what you can for Monday. I think the little explanation of springs I just gave will help for the first 4 questions. Oh, and here's the thing to tell you all also, even though we're going to run out of time today, right at the end of today, of course, I'm going to post in your stream like the PDF of all of the notes of today. And the truth of the matter is I happen to have gotten a little bit farther in those notes with the other class. Like there's some explanations in those notes about conservative forces and conservation of energy and stuff of how to solve problem number 5, like the next question or the next 2 questions on the sheet. You are absolutely welcome to use these. Again, I'm going to remember, I know I didn't say it to you guys, so we'll talk about it on Monday. But anybody who's looking for help with this sheet, with homework number 1, that you just do Monday, look through these notes that you'll get, the PDF of today's lecture notes. It will help you. So again, if you did it, that's great. If you didn't do it, it's no harm, no foul. Nobody should have to worry about homework 2 for Monday, but if you want to, you can. The last thing I just want to ask, hopefully, since someone else just asked this good question, what I just put in your stream, like confirm or deny, please. What I put in your stream is 2 more of the a game assignments. One says take 2. And if you look at it closely, you'll see the take 2 one. It says a game for right or wrong. A game take 2 for right or wrong. And that one does not have a due date. And then it says a game take 3 with no cutesy title. And that one does have a due date. Is that, first of all, is that true? Like, can you confirm that? Do you see that in your stream? Yes. Okay. Thank you, Rachel. That is awesome. Okay. Then, no, you're right. Oh, thank you. You guys are paying attention. Sorry, you're totally right. I just said that take 2 didn't have a date. No, wrong. It does have a date, which is like late May, which is smarter. Right. What am I trying to say with that? First of all, I'm just trying to emphasize with these game things, they are portals. They are meant for you. It's like whatever you want, as long as you're keeping records and stuff, to like, that's why I put the date at the end of May. Any kind of special class participation opportunity like that, you can use at any time. And they have different titles and different weirdnesses. Like that one, again, some of you might remember from last semester, but that one that says for right or wrong, it's for you to make a special note anytime you actually put something in the chat or you actually say something vocally that actually was risky enough that it was either going to be right or wrong. Like you actually say something concrete and quantitative, like, I think the answer to question 1 is 25 newtons. Now, if you have the guts to say, I think the answer is 25 newtons, I want you to get points for that. I want you to remember, like, especially if I then turned around and said, well, that's wrong, actually. It's actually 30 newtons, not 25. I want you to get points for the fact that you went public with something that turned out to be wrong. Like, that's what we have to do as scientists. That's the hardest thing, for, especially in a Zoom class. The hardest thing to do is to be publicly wrong. Nobody likes it. I don't like it. And in science in particular, we get this idea that we're supposed to be right all the time or something like that, because we can tell the difference between right and wrong. But the truth is, science is about being willing to be wrong all the time, to experiment, to live in confusion. So that second portal right there, especially for people who don't know this, you can hold on to that portal for anytime that you remember you put something in the chat or you said something and it was actually specific and concrete enough that I either said that's right or I said that's wrong. Like either way, if you had the guts to go out on a limb and say something that was then going to be publicly called right or wrong, I want you to get the points either way. Frankly, I even want to reward you more if it was wrong in a way, because I think that takes more guts. But so that's what that second one is for. The third one, where it just says a game, take 3 and just has like next week's date on it. That's the thing that I forgot. I think Marissa or someone asked me a few minutes ago, like that's your daily check-in. Like even that you can do late. I don't care if you record that thing 2 weeks from now, but since there should be one of those every day, one opportunity every day for you to participate, I'm putting dates on them just so you can keep track of when you got it or what, for bookkeeping purposes. But so hope you can remind me, hopefully every day there's at least one of those portals for you to get points for doing good things. Okay. These are good questions. Wait, so now I'm catching up. Okay. Oh, I think I missed a question. I'm sorry. Tania asked a question that I seem to have missed. Wait, do we still have to write it out? Oh yeah, right. For the participation or for anything, you can type directly in, as long as the doc means Google Doc. Wait, you can type directly in. It's just, unless I'm misunderstanding something. The one thing I'm trying to get away, what I can't have from you guys, at least as far as I know, is I don't want you handing in, I don't want you submitting image files like JPEG or PNG or GIF. I don't want you submitting those to Google Classroom. It will let you, but that's why I keep warning everybody. It'll let you submit JPEGs, but they're much harder. They don't come through on my side in the same way, and I can't put marks on them. I can't grade them in the same way. It's a little hard to explain, and maybe that's my failure, but they don't come across on my side in the same reliable way, and they slow down the whole system. So you can type, so Google Docs are fine if that's what you're asking. If that, and Tania, I may not be answering your question. I'm not, but let me see the other question. Okay. 1 second. I'm catching up here. 1 second. One second. Sorry. Okay, sorry. 1 second. Okay. Oh God, did I do that again? Oh my God. I mean, Melissa. Okay. All right, I should use my inside voice for this. Okay, I'm just trying to catch up with the chat. I realize I'm already messing up left and right with names that I shouldn't. But I'm just making sure I've answered all these questions. I don't know if I really answered Tania's question. She's welcome to, she's invited to ask it again, because I don't know if I, oh yeah. Okay. But if now it is 4:20. So are we sort of clear for the moment? Okay. I'm good if you guys, I know we didn't get to, I'm sorry, we will get to homework 1 on Monday. Don't do homework 2 unless you like are dying to. And I will get you a syllabus, an official syllabus, but and we'll discuss we'll nail down the midterm on Monday. But I'm good if you guys are good. So I'll stay here I'll try to stay till any questions are answered, but feel free to say goodbye or shout goodbye or text goodbye, and then we'll say goodbye or ask a question.
Hi, Professor.
Hi. Oh, hi. Yes.
Hi, it's Tanya.
Yes.
So by my question, I meant I'm not sure if it was clear last time, but you said something about submitting the participation by writing it actually out on paper and then attaching that file onto a PDF and then submitting it. I'm asking if you want us to write it out on paper, or is it okay for us to just type it out?
It's totally okay to just type it out. You're right. Oh, and I think I see it's totally is okay to just type it out. And now that you mentioned, I think I get what you're saying. You mean like you could even just type it straight into the Google Classroom thing without even having to do an attachment. Is that what you're saying?
Right. So when you create a Google Doc, I'm asking, can we just type in what we said during the lecture instead of like writing it out on paper? And
yeah. Oh no, absolutely. And then I'm sorry. And then submit the Google Doc. You mean yes? You would then yes, absolutely. Okay, to everybody. No, I just wanted to make sure I understood that. Yes. So the truth is, anytime. I mean, this is a yes to everybody. Yes. I'm never trying to force. Anytime I say take out a piece of paper, I'm only saying that because some people still want that and don't want to be forced into a computer. You never have to. No, I'm not saying you ever have to take out a piece of paper. And every time I say PDF to everybody in this room, when I say PDF, if in your brain you understand how to do Google Doc instead, yes, I'll always take a Google Doc. But for some people that's confusing. What I'm really trying to say is I cannot take an image file. And as weird as it is, at least right now, I can't take a Word, like a Word doc. I know they're getting more and more similar and all that, and someday probably, but right. So yes, you can type straight in, and yes, Google Doc is fine. And PDF is ideal. And yeah, you don't have to, oh, and now class is over. I'm sorry. So we should go. But yes, if that answered that question, that is totally, so anybody wants to go. I mean, I don't want to keep anybody. but do say goodbye. But I will be here for any other questions. Like I'm not going. So bye. Bye. Thank you for
Thank
leading.
you.
And thank you, Ardell, for leading. I pray without being asked. Thank you. And bye. And sorry, Melissa or Marissa. I'm so sorry. Oh God. And bye, everybody. Yeah,
Have a nice day.
you have a nice day too. Thank you. Bye. See you Monday. Yes. See you Monday. Sorry to keep you guys. Okay. See you Monday. Excellent. Excellent. See you.